Here we go. We are today going to look at using some more theorems around proportionality, not just in triangles, but in different shapes, but more proportions, more and more proportions. So the first theorem we're looking at is the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionately. Proportionally. So if segment TU is parallel to segment QS, then segment RT is to segment TQ as segment RU is to segment US. This is to this as this is to this. And conversely, if a line divides two sides of a triangle proportionately, then it is parallel to the third side. So if I know these guys make an equal proportion, then I know that segment TU is parallel to segment QS. So let's apply that in a problem. Okay. So in this diagram, if we know that QS is parallel to UT, and RQ is 10, RS is 12, and ST is 6, what's the length of segment QU? So we can set up the proportion using the triangle proportionality theorem. I'm going to just do some abbreviations. Sorry, that's PROP theorem. And now I'm going to start plugging in what I know. RQ is 10. I don't know QU. That's what I'm trying to find. RS is 12. ST is 6. Okay? And then we're going to use cross products property. 10 times 6 is 60. And then 12 times QU. Divide both sides by 12. QU is 5. All right. Let's look at one more. And then you're going to do the checkpoints. You're going to pause the video and do the checkpoints. It's going to be awesome. So this one is more of a word problem situation here. A spoiler for a remote controlled car. That's like that thing on the back of a car on like speedy cars. They have that kind of wing shaped thing that sits up. A spoiler for a remote controlled car is shown where AB is 31. I don't know why they didn't write everything in here for us. Too small, I guess. BC is 19 millimeters. CD is 27. 27. And DE is 23. Explain why BD, segment BD, is not parallel to segment AE. So first we're going to find the ratios of the two sides here. So CD is 27 and DE is 23. CB is 19 and BA is 31. If we check this, if we do the work, this times this is not equal to this times this. So I'm just going to rewrite them here. 27 over 23 is not equal to 19 over 31. And we could check that again by doing, is this times this equal to this times this? And they're not, so it's not parallel. So if I were you, and if I was really on my game, I would pause the video right now, try these two checkpoints, and then come back to me, and I will explain them to you. All right, so let's take a look at how to find the length of KL. This is a lot like example 1. I don't know KL, but I know that this is to 18 as KJ as 44 is to 24. Okay, and then using cross products, I got 24 times KL equals 18 times 44. I'll do the math for you. Divide both sides by 24. KL is 33. And to check to see if those two lines are parallel, we're going to set up a proportion and see if it's true. This is like example 2. So is 36 to 80, that ratio, is it the same as 18 to 38? And again, using cross products property to check, is 36 times 38 the same as 18 times 80? And when I calculated that, I'll do that for you. It's not equal. So no, not parallel. All right, let's look at a few more theorems. All right, this next one is about parallel lines and transversals. If three lines intersect two transversals, if three parallel lines intersect two transversals, then they divide the transversals proportionately. Proportionally. So UW is to WY as VX is to XZ. And this another one here with proportionality in these shapes is 6.7. Unfortunately, these don't have names, and we're not going to be using these in proofs. We're going to be using them just to solve problems. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So if I know this ray is an angle bisector, then AD is to DB as CA is to CB. And then we're going to practice with those. Let's apply those. Example 3 applies this top one. And I am going to actually, on the side here, I'm going to do this a little differently than the book did it. So a farmer's land is divided by a newly constructed interstate. The distances shown are in meters. Find the distance CA, right here, they want me to find this whole one, between the north border and the south border of the farmer's land. So I've got this piece of information, this one, but not this, so I can't get this. They have me using this property of proportions, which, I don't know, sometimes I find a little confusing. So I'm just going to drop an x in there. I'm going to solve for x, and then I'm just going to add it to 2,000. So because these are all parallel lines, I can say, and again I'm just sliding over here, 2,000 is to x as 2,500 is to 3,000. This is to this as this is to this. Cross products property, 2,500x equals 2,000 times 3,000, 6 million. And divide both sides by 2,500. So the unknown distance right here is 2,400. So when I add them up, it's 4,400. The 2,000 plus the 2,400. Again, they did it using this. I find it a little confusing, and I just apply the property in a different way. And then the next example shows us the angle bisection theorem with proportionality. So in this diagram, we know that DEG and GEF are congruent, so therefore we know that EG is the angle bisector of angle E. Use the given side lengths to find length DG. So solution is, because this is an angle bisector, you can apply the theorem. Let's put in x for DG. Then the entire side is 14 minus x. Sorry, the entire side is 14. They gave us that. So GF is 14 minus x. That was given in the diagram. So now we just start plugging in what we know. So GF is 14 minus x. So this side is to this side as 12 is to 8. This is to this as this is to this. And again, we called that 14 minus x. And then we used cross products property again to solve the proportion. 12 times x, this times this, equals this times this. And our book went forward here. They didn't give us a lot of space, but I'm already applying the distributive property for this. Okay. And then when we do our algebraic work and solve for x, we get 5.6. All right, so I would pause the video if I were you, and then just hit play again when you have a chance to work those two problems, and I'll have the solutions here for you. All right, so this one is just like example 3. And we, because these are three parallel lines, we know that this is to this segment is to this segment, as AB is to 27. We're going to use cross products property to say, and then this times this is 864, and divide both sides by 24. AB is 36. And for this one, because we have that angle bisection, BC is to DC as AB, this is to this as this is to this. Okay, and you can, by cross products property, or even we see that they're the same, so we know AB will be the same, but AB equals radical 2.